chain rule is what we use when we want to take the derivative of a composition of functions. A composition of functions is when we have one function inside another function as the argument to it. So my inner function here is g of x, my outside function is f of x, and the chain rule states that the derivative of this is the derivative of the outer function times the derivative of the inner function. Another way we can write this is to say let the inner function equal u, then the derivative of f of u is f prime of u times u prime. Let's use this on some examples. So here we have the function y equals 1 over x plus 1. Now I could take the derivative using the quotient rule. However, if I rewrite this as x plus 1 to the negative 1, then I see it can be done using the chain rule where my inner function is x plus 1. So we'll let u equal x plus 1, then u prime would just be 1, and my outer function would be u to the negative 1, and its derivative would be negative u to the negative 2. So the derivative of my function would be negative u to the negative 2 times u prime, and when we substitute our u back in here and our u prime, then we get negative x plus 1 to the negative 2 times 1, and I can rewrite that as negative 1 over x plus 1 squared, which would be the same answer I would get if I had used the quotient rule on this problem. Okay, let's try another problem. Y equals sine of 2x. My inner function is 2x, and the derivative of 2x is 2. My outer function would then be sine of u. And the derivative of sine of u would be cosine u. So the derivative of the whole thing then would be cosine u times u prime. And if we substitute back in for our u and our u prime, we will get cosine of 2x times 2, and we want to rewrite that with the coefficient out front so we don't think we're multiplying it by the argument to cosine. We'll write that as 2 cosine of 2x. Okay, let's try another problem. In this problem, my inner function is 3x squared minus x plus 1. The derivative of that is 6x minus 1. And we can write our outside function as something being raised to the 1/2 power. So the derivative of that then would be 1/2 u to the negative 1/2. So our derivative is 1/2 u to the negative 1/2 times u prime, and if we substitute back in our u and our u prime, I get 1/2 times 3x squared minus x plus 1 all to the negative 1/2 power times 6x minus 1, and a neater way to write that would be 6x minus 1 over 2 times the square root of 3x squared minus x plus 1. Okay, y equals tangent squared x. I'm going to rewrite this so that I can see the inner function and the outer function. Tangent squared x is just the notation for tangent x all squared. So my inner then is tangent x, and the derivative of tangent x is secant squared x. My outer function then is I have something squared. So we'll write that as f of u equals u squared and f prime of u equals 2u. So my derivative is 2u times u prime, and if we substitute back in, I'll get 2 tangent x times secant squared x. Okay, y equals x squared plus 1, all raised to the third power. Then my inner function here is the x squared plus 1, and its derivative is 2x. My outer function is going to be u cubed. The derivative of that is 3u squared. So the derivative of our function is 3u squared times u prime. And if we substitute back in then, I get 3 times x squared plus 1 squared times 2x. And we need to clean that up, multiply our coefficients together. So I get 6x times x squared plus 1 squared. Okay, y equals cosine of x minus 1. My inner function then would be x minus 1. Its derivative would just be 1, and my outer function would just be cosine of u. The derivative of cosine of u is negative sine of u, and so our derivative would be negative sine of u times u prime, which will give us negative sine of x minus 1 times 1, and we don't need that 1 there when we simplify this. Okay, y equals e to the 3x. So we know how to take the derivative of e to the x, it's e to the x, but in this case we have an inner function because we have a 3x instead of just an x. So we'll let u be 3x, then u prime is 3. My outer function would be e to the u, and its derivative would also be e to the u. So for our function, we'll get e to the u times u prime, which is actually e to the 3x times 3, and we want to rewrite that with the coefficient out front. Okay, one more here. I have cosine of 3x squared. So my inner function is 3x squared, and the derivative of my inner function then is 6x. My outer function is cosine of something. So we get cosine of u, and its derivative is negative sine u. So for our function, we get negative sine u times u prime is negative sine of 3x squared times 6x. And if we move our coefficients out front, we'll write that as negative 6x times sine of 3x squared.